Well, hello everyone. I want to thank you for joining me for this presentation of tools for evaluating drought impacts on non-forest vegetation. This is, of course, part of the Healthy Public Lands Conference that you are all attending. My name's Matt Reeves. I work with the Rocky Mountain Research Station in Missoula, Montana, where I focus exclusively on rangeland issues. When we're talking about drought, it's important to be on the same page that not all droughts are the same. And oftentimes we get conflicting messages or conflicting evidence. One indicator might tell us we're droughty, the other one might tell us we're not droughty. So to avoid some of this, it really helps to be clear about what the target is when we talk about drought. Again, not all droughts are the same. An example of this would be that drought is not one-to-one with forage. As in the case of the Southwest right now, we see an awful lot of grass on the ground from last year, but it's really dry, so a lot of the stock tanks are dry. One metric, droughty, the other metric, not so much. So it really helps to define what we mean when we say drought. So one of the most important things for you to focus on right now would be to get a process that works for you. Your process is probably going to look a lot different than mine. And it's also apparent there are way too many tools. You're going to spend an awful lot of time and come up empty-handed if you go on a fishing expedition with respect to drought. So again, it helps to define what it is we're looking for. And if you don't know anything else about the tools, you don't know where else to start, I recommend you go to the National Integrated Drought Information System, or NIDIS. It is a total treasure trove of information, but beware you can get lost in there because there is so much information. So you should have a picture in mind about what you want before diving into a bunch of these data systems. So if we establish the appropriate workflow, it's going to help us answer the question you're after. But again, just answering the question, are we in a drought, is not very helpful. We need to be more specific about where are we talking about, over how long, what kind of impacts are we interested in, importantly, what kind of output do we want? Maps, charts, squiggly lines, what is it? So all these factors will help us determine the type of tools and workflow we need to be successful. So what I'd like to share with you briefly in the rest of the presentation is generally my recipe for how I do it. Okay, the first question I like to answer is where have we been in terms of vegetation trend? For example, is productivity going up, down, or sideways? But also the drought trend. Where have we been in the past and what were the impacts? Second question is where are we right now? That's a different kind of tool set. And finally, we want to look at where we're headed, which of course is much more difficult. Now, each of these time tranches can be a different tool set, but it doesn't have to be. Some of these tools will do multiple of these time tranches at one time. It just depends on the question you are asking. So in terms of answering that first question, where have we been looking at vegetation trends, I like to look at using either the Rangeland Analysis Platform, a very good tool, or the Rangeland Production Monitoring Service, which is my own tool. Not as good of a platform, but equally as good of data. Some of those data are shown here. On the X, we see time, on the Y is production in pounds per acre. So out of this one area I chose to examine just for this slide, for this presentation, we see a couple of things that are really interesting. First, post-2000, we see doubling of variability in the system in terms of production. The highs are higher, but the lows are definitely getting lower, so variability is doubled. The second thing is, since 2015, we've seen 4 of the lowest production years on record. This is surely going to influence how we interpret new droughts that are going to be forthcoming when we see these kinds of signals. So it's important to look backwards to understand what some of the forward-looking indicators will ultimately mean. So another way of looking at trend over time is in mapped format. You can use the Rangeland Analysis Platform information or the Range Production Monitoring Service information to map trends over time. Here we have simple correlation with each of these life forms, perennials, annuals, and trees with respect to time on the Kaibab National Forest. Red tones tell us areas where over that time period from 1985 to 86 to present day, where the life form has been decreasing. The converse is true with cool tone. So if you take a look at the tree panel, that tells us areas where the PJ and the pea pine has been increasing over time. And with respect to drought, these might be the areas that might be candidates for treatments to enable more soil moisture to occur after rainfall, because we would reduce perhaps the transpiration from these trees. Another great tool when I'm visiting with managers and others to quickly demonstrate the general conditions in an area with respect to the vegetation performance, I go to PhenoMap. Now, PhenoMap in this case is showing me that eastern and south central Washington, that area in the Columbia River Basin, for those of you that know that geography, is doing quite well. You'll also know that if it's doing quite well in the Columbia River Basin, that's a lot of cheatgrass there. So what we're seeing is a tremendous pulse in cheatgrass, and you could tell this within 30 seconds of invoking the tool, that we're doing relatively well in the case of eastern Washington. Now, if you were to look around the United States, you could find areas where you would see the reddish tones, areas where vegetation is underperforming. But a quick look at PhenoMap gives you a lot of power to discuss a map in amongst yourselves, and it also tells us, where we're at relative to a pretty long time period. Because this is driven by MODIS, it's roughly 2000, I believe, or 2003 to roughly 2022. So it gives us a nice long time period to look at the vegetation conditions very rapidly. Well, taking the PhenoMap data one step further, if we focus on the red dot in the upper left-hand part of your screen, which is near the Hanford reactor, for those of you that know this geography, what we see is a temporal profile, shown here. On the x is time, and on the y is a simple unitless metric. But it tells us, relative to all the other time periods from, say, 2002 to 2022, we've only been here 2 or 3 times in the past. So that tells us we're entering some quite remarkable conditions, presumably driven by mostly cheatgrass in the Central Basin. Now, since this is a drought conference, we should be looking for, where the conditions are reversed. Where did we see drought conditions? But a bit of good news here. Eastern Washington is doing pretty well. So what you see on your screen right now is, in my opinion, one of the most well-developed and most powerful data retrieval engines out there today for resource professionals like yourselves. And that's called Climate Engine. And what we see here, just as an example, is precipitation difference from average, okay? And it's over the last 90 days. And it compares up to clear back to 1979 as the baseline, if you want it, as it uses the GridMet climate data system. So again, this is an extremely powerful system, and there is a ton of different kinds of climate metrics. There's climate metrics, there's drought metrics, there's some land surface metrics on here, and it's really worth exploring. If you use no other tools for your drought exploration and you're just starting, I would encourage you to consider the use of NITIS for sure, and Climate Engine to follow it up. You're going to find almost everything you need within those two platforms, especially when you're just starting out. Many of you know that I'm fond of warning you not to get head faked. What I mean is, take precipitation, for example. We might use precipitation as our indicator that we like to use in our toolbox as the #1 indicator. But what if it's really hot? And what if it's been really dry? Is that moisture going to be effective and soak into the soil? Maybe not. Using the CropCasmo, or the Crop Condition and Soil Moisture Analytics program, this tells us the actual soil moisture conditions. So it accounts for all the variables that our minds really have a hard time with. Now, this is from a satellite that was launched in 2015 by NASA, so it's not really modeling here, but it's actually soil moisture being measured, granted from maybe 700 kilometers in space. But I find that it gives us a tremendous advantage when we want to look at what's happening right now and what that might mean for the vegetation performance in the near term. So enough about talking where we are at. It's time to start talking about where we think we're headed, which of course is much more difficult. Almost all the systems are good at looking backwards, but the jury's still out on systems that look forward. It's very difficult to make predictions, especially about the future. But one of the tools I like to have in my toolbox is right here. It's a USDA website, and it contains an awful lot of drought prediction monitoring tools, in addition to suggested conservation practices and forecasting mechanisms that you can use to see what the experts are thinking in your neck of the woods. One of my favorite tools to use is called FuelCast. It's one of my favorite tools because we created it. There are other tools that sort of emulate FuelCast. For GrassCast, for example, might be another choice you'd want to use, especially in the grassland regions of the United States. But what FuelCast does is it looks ahead 4 months and begins making projections about the annual productivity based on the daily precipitation, the eddy, which is a NOAA drought formulation, and a weekly remote sensing data feed. It blends all that information together and makes forecasts on the Google Earth Engine platform. So this is a deployed artificial intelligence application, and it does operate on the Google Cloud platform and gives us a picture of not only the 1 hour fuel, the fine fuels, which is also forage, but it tells us this information at least 4 months in advance. In some cases, it's much more accurate than others, but that's another day and a different discussion. So one of the things we do with all this information, including that with FuelCast, is blend it all together to talk about what we're seeing around the West in terms of forage and fuel conditions. And in that, it's captured in our Reading the Tea Leaves, which is a monthly webcast that we offer. It's a monthly month and a half-ish. Each episode's 10 to 15 minutes plus or minus, but we bounce around the country and talk about where the needle's really moving. One of the things we were really pounding the table on with respect to FuelCast and what it's telling us was the Southern Plains, particularly northern Texas. In February, we said this was going to be extremely problematic. Forage was going to be well below normal, as shown by the warm tones here. And I think that forecast is bearing out to be true. If you're a producer in this neck of the woods, you know exactly what I'm talking about. Now, I recognize that not everyone is an analyst. And in my position, I do this sort of thing every day, but other types of positions may not be quite this analytical. So for some of you, perhaps a good tool to use would be some of the narratives. You know, there's a ton of different kinds of podcasts out there, but here's 3 that I think are worth a consideration if you're one of the types that likes a narrative. Doug Cluck with NOAA does a fantastic job with his monthly North Central U.S. Climate and Drought webinar series. I love it. I get a ton of information there, especially about impacts to the different resources in that neck of the woods. And also Dan McAvoy with the Desert Research Institute does a great job with the NOAA West Watch. It's not as often as the monthly series by Doug Cluck, but boy is it rich. It includes stuff including even sea surface temperature and ENSO and PDSO and all these things. I mean, it has a ton of information there. Finally, there's my own webcast, which is called Reading the Tea Leaves. This is where we take all kinds of information and talk about what we think is going on and what is forecast to happen with respect to forage and fuel. Now, 3 of the things we've talked about this year alone, where the Central and Southern Plains are in really bad shape, we called the McBride Fire and others in that region at least 2 weeks ahead of time, and we also called the cheatgrass explosion that's happening right now in the Columbia River Basin, but also the pulse in northeastern California of uncharacteristically large growth. Well, I'd like to thank you all for spending some time with me today, and I remind you that, find a tool or a process that works for you so that you don't have to spend a lot of hours visiting dozens of sites. Pick a few tools that work for you. Maybe it's something as simple as rainfall, and that helps you communicate your message, which, by the way, communication is one of the most important aspects of drought, in my opinion. Accurately and effectively communicating the impacts of drought is the #1 thing that we need to be doing. So find one that works for you and stick with it. Also, be very specific and qualify the drought question you're asking. What time frame? What impact of drought are we looking at? What spatial scale? Local, regional, national? And what kind of output? Again, do we want the squiggly lines? Do we want maps, bar charts, animations? Those are available too. What's the best to help you make your point? And finally, if all of these fail and you don't know where else to turn, get help. There are a ton of researchers, both in academia, nonprofits, also in the government, that can help you understand the tools and resources available to you, especially myself. I would be very glad to help any one of you understand any of these tools in more depth. Enjoy the rest of the conference, folks.